Hello, intermediate algebra students. This is once again Miss Leminski, one of the teachers at Edina High School. And today we are going to watch the video learning about the second half of what we need to know for the cube root function. Before we get into today's lesson, though, I would like you to start with this warm-up to review what we did yesterday. So today we're going to look at these two questions, and I want you to describe how the graph of the function compares to the graph of the parent function cube root of x. So pause the video and write down what is happening in this situation. In this example and in this example. Okay, so hopefully you were able to look at this and recognize that the x minus 2 that is underneath the cube root would move it to the right 2. Remember, when it's under the radical, it's with the x, which means it impacts the inputs, which moves it left or right, but the opposite of what you would think. And then hopefully you were able to recognize that the plus 4 moved it up 4. When it's outside of the radical, it moves it up or down as you would think, because it's affecting the y values or the outputs. For number 2, you should have said that it moved left 1 and down 9. So that's just a little warm-up to review what we learned yesterday. But now we are going to get into the second half of the function, or what we need to know for the cube root function, and that is how do you find the average rate of change and how do you compare on different intervals for the cube root function. And again, this will be very similar to what you learned about the square root function in the second video for that as well. One thing that's unique about the cube root function, though, when we have to type something into our calculator, unfortunately it does not have a cube root button. So when you did square roots, you were able to just simply do control x squared because that gave you the square root. Having said that, we need to understand that the cube root of x is the same as x to the 1/3 power. So anytime you need to graph this on a calculator or to figure out a value, which is more so what we'll need to do, you need to be able to type it to the 1/3 power. So when you put a number in, remember to do an exponent. You're going to use this button, the caret key, and then it'll give you an exponent, and then you would just do 1 divided by 3. Okay, and we'll see how we can do that later in the lesson today. All right, so like I said, the first thing we need to be able to do for today is just to be able to calculate the average rate of change. And as a reminder, you did this with the square roots as well, and we did it last chapter. But average rate of change is the same as finding basically the slope, but between two set points. And the equation for slope, remember, is y2 minus y1, so the change in y's divided by x2 minus x1, changes in x's. So in order for you to find average rate of change, I would have to give you two separate endpoints, and you're going to start by plugging those in. So first I'm going to do f of 1. And this is my function, so I'm going to take the cube root of, instead of x, I'm going to put 1 minus 1. So I take the cube root, 1 minus 1 is 0, and the cube root of 0 is 0. Which means that for the endpoint of 1, I have the ordered pair 1, comma 0, an input of 1, an output of 0. And then I do the same thing with 5. I do f of 5, which gives me the cube root of 5 minus 1. Which is the cube root of 4, which, as we learned, that is not a perfect cube. Okay, so instead, I'm going to have 4 to the 1/3 power. So I did an input of 5, and when I plugged that in, I got an output of 1.587. Now, I told you that I would show you how to type that in, but I'm actually going to wait until I'm done with this slide, and then I'll go to the calculator and show you. Okay, but here's the thing. Right now I just have two ordered pairs. Now I need to use this idea and find the slope between them. I'm going to call this x1, y1, and this x2, y2, which means to find the average rate of change between the 2 points, I would take y2 minus y1, so 1.587 minus 0 over x2 minus x1, so 5 minus 1, I get 1.587 over 4. Type that into my calculator, and I got 0.397. So in the interval from 1 to 5, I get an average rate of change of 0.397. Now, the next question is, what is the average rate of change from 5 to 9? So if you're feeling confident in this, I would like you to pause it and try that on your own. If you're not totally confident yet, you can just keep watching. Okay, so again, I promise I will show you on the calculator how you can type this in, but if you didn't understand from the previous video, but again, we should be okay for this one. First thing I need to do is use an input of 5. Now this should make sense, we actually already did it. So we're going to do cube root of 5 minus 1, which is the cube root of 4, which we already calculated. 4 to the 1/3 is 1.587. Again, I kind of told you that's what it was, and we will see how to type it in. Which means that the first pair is 5, 1.587. But the other value we want to plug in is 9. So with an input of 9, I get the cube root of 9 minus 1, which is the cube root of 8. And that is a perfect cube. What times itself 3 times is 8, and that's a value of 2. Which means that it's an input of 9 and output of 2. Again, now we're going to use our slope formula. And so I have an x1 and a y1 and an x2 and a y2. So I'm going to do 2 minus 1.587 on top, y2 minus y1, over 9 minus 5. 2 minus 1.587 is 0.413. Divided by 9 minus 5 is 4. I divide those by each other and I get 1.103. Okay, so those are my 2 average rates of change for this problem. Now the follow-up question is, what do you notice and what do you wonder? And so one thing I notice is that the slope in the first one was bigger or steeper than the slope in the second one. Okay, so it got steeper, but so from here to here, it actually gets less steep. The slope does. But if I compare what's happening from this, I was just going from 1 to 5, and now I'm going from 5 to 9. So what I notice is that it gets less steep as x gets bigger. Or as I get further away from 0, it's getting less and less steep. So what I wonder is, well then, when is it the most steep? So let's do one last example to look at that. Okay, so now we're going to look at some negative numbers. Before we do this, though, I am going to go to the calculator, and I have to leave this. That's why I didn't want to do it mid-problem. And as a reminder, if you don't have your own calculator, you're going to go to Schoology, right under the distance learning folder. I do have the online graphing calculator there. I think all the teachers have it somewhere. Click start, and you have to go up here. Okay, so on the last example, we did 4 to the 1/3. So I'm just going to show you how I typed it in. Again, I would hit the 4 first, that caret key I showed you, and then you're going to do 1 divided by 3. Enter. And you can see how I got the 1.587. I rounded to 3 decimal places. Okay. In this example, we are going to end up with 2 times the cube root of negative 15. So I just want to show you how when I have 2 times the cube root of negative 15, I'd still have 2 times, but the cube root of negative 15 would be negative 15. Make sure you put the negative 15 in parentheses to the 1/3 power. So again, we'll talk about why we get that, but you can see when I do type that in, 2 times negative 15 to the 1/3 power, I get negative 4.932. All right, so now let's go back and work through the notes. I'm going to have to click through here. Okay, so we're going to compare the average rate of change for this function over the intervals negative 12 to negative 8. So again, I start with f of negative 12, 2 times the cube root of negative 12 minus 3, and that's where I get 2 times the cube root of negative 15. That's the one I just did. We did 2 times negative 15 to the 1/3 power. And we got negative 4.932. Then I have to plug in negative 8. So this gives me negative 12, comma, negative 4.932, out of space. 2 times the cube root of negative 8 minus 3 gives me 2 times the cube root of negative 11. Again, I would type in 2 times negative 11 to the 1/3, and I got negative 4.448, which means for an input of negative 8, I get an output of negative 4.448. Again, I have an x1 and a y1, an x2 and a y2. And then to find my rate of change, I would do negative 4.448 minus negative 4.932. So I do have a double negative there. Over negative 8 minus negative 12, which again is a double negative. I type those into my calculator. I get 0.484 over positive 4, and I get 0.121. Okay, so from negative 12 to negative 8, I'm far away from 0. I have a 0.121 average rate of change. And now for these values, I'm getting closer to 0. So I want you to pause and show your work for that. What you should have gotten is f of negative 4 is 2 times the cube root of negative 4 minus 3, 2 times the cube root of negative 7, which is the same as 2 times negative 7 to the 1/3, which should have given you negative 3.826, which is the ordered pair, negative 7, negative 3.826. And then f of 0 is 2 times the cube root of 0 minus 3, 2 times the cube root of negative 3, which is 2 times negative 3 to the 1/3. So when you typed all that in, you should have gotten negative 2.884. When you did y2 minus y1, you should have had negative 2.884 minus negative 3.826 over 0 minus negative 7. When I subtract on top, I get positive 0.942, and on bottom I get a positive, this is minus 4. 0 minus negative 4. I wrote it wrong here. That was the wrong one. Okay, so I get over 4, which is in fact 0.236. Okay, so once again, if I compare my first rate of change to my second one, I see that it gets bigger and I'm getting closer to 0. So the big takeaway from this is it gets steeper the closer I get to 0. Okay, so we can talk about how the rate of change changes as we get further and closer to 0. This is where you should pause this, and if you don't have some of these on your notes, you would want to get them added in. Example 1 and 2 is what we just walked through, but at the bottom, you can see that I drew a picture and I summarized it as x gets closer to 0, the average rate of change gets bigger, and as x gets closer to 0, it gets more steep. That's another way to think about it. So we look at this middle part, and you can see I said more steep. Really, you can draw kind of lines through there. You can see a steep line goes through those, but if I'm going through 2 points further out, the line gets flatter. So make sure you pause this and have all of this in your notes. And then to summarize, again, the cube root function, this is a summary of everything. It looks like the picture we show in the graph. That's the cube root of x. F is increasing over the whole domain, and then the key features, as we learned in the first lesson, are the x and y intercept are both 0, and the domain and range are always all real numbers. In interval notation, we write that as negative infinity to infinity. So that is the end of section 10.2. You should now continue on and do your day 2 homework assignment on Pearson, and let your teacher know if you have any questions. Thank you.